There's a way to pull electricity out of the ground, so simple it sounds like a lie the first time you hear it. No fuel, no solar panel, no spinning turbine, no gasoline, no wall outlet, no power company. Just two different metals pushed into wet soil, connected by wire, and the earth begins giving something back. Not heat, not static, electric current. A weak current from one pair, yes, but real, measurable, usable. Stack enough cells together and that quiet reaction becomes light, charging power, emergency energy, and proof that the ground under your boots is not as powerless as you were taught to believe. That should bother more people than it does. Because the moment electricity becomes something an ordinary person can generate with dirt, moisture, and a few cents worth of metal, an entire story starts to crack. The story that power must come from a company. The story that usable energy must arrive through expensive hardware, fragile systems, subscription-style dependence, or complex equipment sold back to you at a premium. The story that if the grid goes dark, you go dark with it. But buried underneath that story is an older one. A clockmaker in Scotland discovered that the soil itself could become part of a battery. Farmers experimented with buried metal systems that produced a steady electrical effect over long periods. Inventors, tinkerers, and practical mechanics kept running into the same law of nature from different directions. When two dissimilar metals meet moisture-rich earth, electrons begin to move. Quietly. Constantly. Predictably. And that is where this story becomes dangerous. Because once people understand that the planet itself can act as an electrolyte, electricity stops looking like a product and starts looking like a relationship between materials. The soil is not making energy out of nothing. It is enabling an electrochemical exchange. The moisture, minerals, salts, acids, and microbial activity in the ground allow one metal to give up electrons more easily than the other. Connect the two, and current begins to flow. It is simple enough for a child to assemble, which is exactly why nobody built an empire teaching you how. Think about how strange that is. We live in a world where people are taught to fear power loss constantly. Storms, blackouts, dead phone batteries, remote campsites, emergency radios with no charge, flashlights that fail when you finally need them, portable power stations that cost hundreds, solar panels that depend on clear skies and open light, disposable batteries that leak, die, and have to be replaced again and again. And yet, one of the oldest, cheapest, most quietly fascinating methods of generating low-voltage electricity almost never appears in mainstream survival guides. Why? Because it does not fit the modern business model of energy. You cannot lock up wet soil in a branded package. You cannot patent copper. You cannot patent zinc. You cannot patent the electrochemical series. And you cannot build long-term dependence around a method that teaches people to look down at the ground and realize they have been standing on part of the system the whole time. That is what makes the Earth battery more than a science trick. It is a psychological threat. It reminds people that useful power does not always have to come from above them, through a utility, through a battery brand, through a glossy emergency catalog product, or through some sealed black box they are told not to question. Sometimes it comes from understanding a basic law of chemistry better than the people trying to sell you a replacement for it. And once that thought gets into someone's head, it does not leave easily. Because the next question comes fast. If this method is real, if it is old, if it is simple, if it actually works, then why did almost nobody teach it to you? The answer starts with chemistry. Because once you understand the reaction, the mystery disappears, and the power of it becomes even stranger. An Earth battery is not magic. It is a galvanic cell using the ground as the working environment. Two different metals are placed into moist soil. One of those metals is more reactive than the other, which means it gives up electrons more easily. The other metal holds on to them more tightly. The soil between them is full of water, dissolved minerals, salts, organic compounds, and microbial activity. That wet, mineral-rich environment allows ions to move. The moment you connect the two metals with wire, electrons begin traveling through the circuit. That flow is electricity. Not imagined, not symbolic, not almost electricity. Actual voltage you can measure with a meter in seconds. This is the same underlying principle behind the battery inside a flashlight, a remote, a vehicle, or a phone power bank. The difference is that instead of using a sealed chemical paste inside a factory-made cell, you are letting the Earth itself act as the electrolyte. The chemistry is older than modern industry, older than the portable power market, older than any survival brand now pretending power only becomes real when it comes shrink-wrapped in plastic. And the metals matter. Copper paired with zinc is one of the classic combinations because it is cheap, accessible, and reliable. Zinc is more reactive, copper is less reactive. That difference creates the voltage potential. Put them into conductive soil, and a single cell can produce roughly around 0.8 to 1.1 volts, depending on soil quality, moisture, spacing, temperature, and metal surface area. Use magnesium instead of zinc, and the voltage can climb even higher because magnesium is more reactive. Use poor soil, dry conditions, or weak contact, and output drops. That is the part most people never hear. The Earth battery is real, but it is also honest. It obeys conditions. It gives you exactly what the chemistry allows, nothing more, nothing less. Which is why the technology was never going to replace power plants, but was always valuable for low-power systems, experiments, signaling, clocks, sensors, lighting, and emergency use. That distinction matters. A lot of people dismiss old technologies because they imagine a false choice. If it cannot run an entire house, it must be useless. That is nonsense. A compass does not replace a highway, but it can still save your life. A tarp does not replace a cabin, but it can still get you through a storm. Low-power electricity in the field works the same way. It does not need to be everything to be important. And this is where the buried metal setup becomes more interesting than it first appears, because one cell is weak, but cells can be stacked. Take one copper electrode and one zinc electrode in wet ground, and you get a small voltage. Build 10 cells and connect them in series, positive to negative, and those voltages add. Build 15. Build 20. Suddenly you are not talking about a curiosity anymore. You are talking about enough electrical pressure to run LED lights, power a small radio, trickle charge a capacitor bank, or feed a regulated output system for USB-level devices if the current is managed properly. That is the leap people miss. The Earth battery feels laughably simple at the beginning, so they assume the result must be trivial. But survival is full of systems like that. Fire starts with a spark. Shelter starts with a ridgeline. Water security can start with one clean container. Power can start with a reaction so small you can barely see it, until you multiply it. And once inventors in the 1800s realized that, the idea stopped being a novelty and became infrastructure. That is why early experimenters were so obsessed with it. They were living in a time when electricity still felt half miracle, half mechanical fact. To discover that soil itself could be part of a working circuit was not a science fair trick. It was a crack in reality. It suggested that useful current was not confined to laboratories or elite institutions. It could be coaxed out of fields, gardens, roadsides, riverbanks, and damp ground behind a workshop. A person did not need a giant machine. He needed understanding. And in the next part, that is where the story changes from chemistry into conflict. Because once low-cost electricity moves out of the workshop and into the real world, every industry built around selling controlled access to power has a reason to make sure it stays forgotten. The moment a simple idea becomes useful, it stops being just science and starts becoming economics. That is what happened to the Earth battery. As long as it looked like a curiosity, nobody cared. Two metals in wet soil making a needle twitch on a meter is interesting, but it is not yet a threat. The threat begins when people realize the reaction is stable enough, cheap enough, and scalable enough to do real work. A clock can run, a signal can travel, a light can glow. A low-power device can stay alive without fuel, without sunlight, without a store-bought battery pack, and without anyone's permission. That is where the silence around this technology begins to make more sense. Because the modern energy world does not just sell electricity, it sells controlled electricity, metered electricity, branded electricity, portable electricity wrapped in plastic, patents, safety labels, chargers, subscription ecosystems, and recurring replacement cycles. Every part of that system depends on one core belief, that power must arrive through something complicated enough to justify the price. The Earth battery insults that belief. It says the ground can participate. It says chemistry can do quiet work for free. It says low-power electricity can be assembled by ordinary hands. And worst of all, it says some useful forms of energy are too simple to own. That is a hard thing to build a business around. You can sell a solar panel, you can sell a generator, you can sell rechargeable battery banks, charging cables, inverter stations, fold-out arrays, branded lanterns, emergency kits, and power subscriptions. But you cannot easily build a high-margin consumer empire on damp soil and 2 strips of metal. That is why this kind of knowledge always gets pushed into the margins. Not because it is debunked, not because the chemistry fails, but because it lives in an uncomfortable category. Too real to dismiss, too limited to become mainstream infrastructure, and too cheap to become a premium retail obsession. So it gets treated like a novelty, a classroom demonstration, a weird old experiment, a historical footnote, anything except what it really is, a low-cost, low-power, off-grid method with real survival value. And that survival value becomes obvious the moment you leave the fantasy world of unlimited outlets. Imagine a wet week in the woods, heavy canopy overhead, solar performance collapsing under cloud cover and tree shade, disposable batteries already half dead from cold nights. A power bank drained faster than expected because someone kept checking weather updates or trying to hold a weak signal. In that situation, Most people start thinking only in terms of what they brought with them. The Earth battery changes the question. Now the question becomes, what can I generate here? Not huge power, not luxury power, practical power. Enough for a small LED, enough for signal support, enough to keep an emergency receiver alive, enough to charge gradually instead of not at all. Enough to stretch options, and in a survival situation, stretching options is everything. Because that is how overlooked technologies matter. They matter in the gap between zero and enough. And that is exactly the zone modern marketing ignores. The survival industry loves dramatic hardware, big wattage numbers, rugged cases, foldable panels, tactical branding, expensive preparedness. But actual self-reliance often lives much lower down, in methods that are slower, simpler, uglier, and far more independent than the shiny solutions people are trained to admire. That is why the Earth battery belongs in this conversation. It does not compete by being flashy. It competes by being stubborn. It works in the dark. It works under trees. It works when there is no gas. It works when you are far from a store. It works when the only thing you still have is wet ground, basic metal, wire, and the patience to build cell after cell until the voltage climbs into usefulness. And once someone understands that, the whole psychology of power begins to shift. Electricity stops feeling like something you either buy in full or do without entirely. It starts feeling modular, negotiable, something you can coax, build, accumulate, and improvise from basic materials if you understand the laws involved. That is a dangerous idea in a world built on dependency, because dependency is profitable. And in the final part, we are going to do the most important thing of all: strip away the myth, build the system in plain language, explain exactly where it helps, where it doesn't, and why even a small source of free electricity can completely change an off-grid plan when everything else starts failing. Now we get to the part that matters most, because a hidden idea is useless if it stays trapped as a story. If you want to build an Earth battery, start with the simplest, reliable setup: copper and zinc. Copper wire works well for one side, galvanized nails work well for the other, because the zinc coating becomes your reactive metal. You do not need a laboratory, you do not need a machine shop. You need moist ground, basic wire, and enough patience to build more than one cell. The first step is choosing the right location. Wet soil matters more than almost anything else. Damp garden beds, forest floors, dark soil near streams, rich ground with organic matter, and earth that stays cool and moist will outperform dry sand every time. The reason is simple. The soil is acting as the electrolyte. If the ground is bone dry, ion movement drops and the cell weakens. If the ground has moisture, salts, minerals, and life in it, the reaction improves. Next, place one copper electrode and one galvanized nail a few inches apart in the ground. Keep them separated so they do not touch. Connect a wire between them through a multimeter and you should see a small voltage reading. That is one cell. Small, yes, but real. Then you scale. That is where the Earth battery stops being a curiosity and starts becoming useful. You build another cell, then another, then another. Connect them in series so the voltage adds from one to the next. 10 cells can move you into a useful low voltage range. 15 or 20 can push farther, depending on soil conditions, electrode quality, and spacing. The system is slow, quiet, and unimpressive to look at, which is exactly why people underestimate it. But off-grid survival has never been about looking impressive. It is about making simple systems work when more glamorous systems fail. And that brings us to the most important truth about this method. It is not for everything. You are not running a refrigerator with this. You are not powering a cabin like a full solar bank. You are not replacing a generator during heavy load use. That is not what this is for. This is for the narrow, critical zone where small power matters a lot. Emergency lighting, tiny radios, sensors, signaling, trickle charging support, extending the life of other systems, feeding stored charge gradually instead of having no incoming energy at all. In survival, the difference between not enough for comfort and enough for function is enormous. One little light during a blackout matters. A few extra bursts of communication matter. A slow charge that keeps a dead phone usable for one more emergency contact matters. That is where Earth batteries earn their place. But you should know the limitations honestly, because real knowledge includes the weaknesses. Soil moisture changes output. Dry conditions reduce performance sharply. The zinc side corrodes over time because that metal is being consumed by the reaction. Bad connections waste power. Poor regulators waste power. And the current is low, which means impatience ruins expectations fast. If someone expects instant, high-output convenience, this method will disappoint them. If someone understands accumulation, low-power use, and emergency flexibility, it becomes much more valuable. That is the difference between fantasy preparedness and real preparedness. Fantasy preparedness wants one expensive device to solve every problem. Real preparedness builds layers. Fire plus insulation, stored water plus filtration, carried batteries plus charging options, primary gear plus backup methods. And when it comes to power, the Earth battery belongs in that second category. Backup knowledge that becomes extremely powerful the moment first-line systems start failing. That is why this idea survived for so long. Not because it was flashy, because it was true. Two dissimilar metals, wet earth, a completed circuit, current flowing because chemistry does not care whether a corporation profits from it. That is the part worth remembering. The ground under your boots is not a wall between you and electricity. Under the right conditions, it is part of the path. And once you understand that, power stops feeling like something handed down only through outlets, fuel cans, and expensive gear. It starts feeling older than that, simpler than that, closer. And maybe that is why ideas like this fade so easily from public memory. Not because they fail, but because they remind ordinary people of something industries hate. Self-reliance often begins with basic laws of nature that nobody owns.